Welcome to Eugenius Panda Virtual Labs, where students and teachers access the virtual laboratory simulations for various science subjects.
Hello, dear learners. Today, we are going to build atoms. According to Rwanda Education Board curriculum, this lesson is in Unit 5 of Senior 1. Do you remember what an atom is? Do you remember their subatomic particles? Do you remember the subatomic particles? Do you also remember what characterize atoms? Let's find out the answers for these questions before. Let's find out the answers for these questions before we build atoms using the simulation. And before we dive deep in today's lesson, let's have a look at the objectives of our lesson. At the end of this video, you should be able to describe the subatomic particles and build atoms using the simulation and describe their characteristics. Let's have a look at some definitions, some important definitions. As we said, there are some questions we have to find out their answers before we build atoms. What is an atom? An atom is the smallest particle of an element which retains the properties of that element, the smallest particle of an element, which can exist on its own and it retains the properties of the parent element. Now let's go to the subatomic particles. We know three main subatomic particles. Those are protons, electrons, and neutrons. The protons and the neutrons are found in the nucleus, and they are responsible for almost all of the mass of a given atom. Electrons are found on the energy levels or electronic shells around the nucleus. And then protons, they are positive subatomic particles. As I said, we find them in the nucleus. Electrons, they are negatively charged and they are found on electronic shells. On the other side, on the other hand, neutrons, they are so called because they are neutral. So they are the neutral subatomic particles which are also found in the nucleus. The mass of a proton is 1 atomic mass unit, and it is equal to the mass of a neutron. So protons and electrons have opposite charges because a proton is positive and an electron is negative. And that is the reason why in a given atom, if the number of protons is equal to the number of electrons, the atom will be neutral. And to get the mass of an atom, which is located in the nucleus, we sum up the number of protons and neutrons, and then we get the mass. What is mass number? What is atomic number? Isotopes, cation, and anion. The mass number is the total number of protons, as I said, and neutrons in the nucleus of a given atom. If you want to find the mass of a given atom, the mass number, which is symbolized by letter A, you sum up the protons, all protons in the nucleus, and neutrons in the nucleus, and then you get the mass number. So mass number is, we can give the formula, it is A, which is equal to the protons plus neutrons. Atomic number, it is symbolized by Z. It is the total number of protons in the nucleus of a given atom. In a neutral atom, it can also be given by the total number of electrons, because in a neutral atom, the number of protons is equal to the number of electrons. But then we consider the number of protons, it is better because it doesn't change. For a given atom or element, the number of protons will always remain the same, but number of electrons can change when an atom loses or gains electrons. So here we have the formula. how to get the mass number. You add the atomic number to the number of neutrons, or simply the number of protons and the number of neutrons. What are isotopes? Atoms of the same element which have different mass numbers, they are called isotopes. Here we can give the example of chlorine 35 and chlorine 37. They have different masses. This one has an atomic number of 17, atomic number is 17, and here the mass is 35, but here the mass is 37. So these are two isotopes of chlorine. What is a cation? What is an anion? When an atom loses electrons, it can be a single electron or many electrons, it gets a positive charge. And as it becomes charged, we call it a cation or a positive ion. Cation means a positive ion, an atom which has lost. An anion, it is an atom which has gained electrons. It can be a single electron or many electrons. And because when gaining electrons, the number of electrons increase, to mean that the negative charges increase, while the positive charge of the protons remain constant, then we get an overall charge of the anion, which is negative, because the number of electrons is greater than the number of protons. The number of negative charges is greater than the number of positive charges, so the overall or the net charge will be negative. For a cation, the number of protons is greater than the number of electrons because some electrons have been lost. So we have the positive charges, which are greater in number than the negative charges, and the overall will be a positive charge, the net charge of our cation. How do we represent an atom? A conventional representation of an atom is like this one we have here. You remember what A is. This is the mass number. Z is the atomic number. And this X is the symbol, element symbol. And then here we have the charge. If it is a neutral atom, there is no charge. If it is a cation, there will be a positive charge, and the magnitude of the charge will be equal to the number of electrons that have been lost. And if it is an anion, there will be a negative charge with a magnitude that is equal to the number of electrons that have been gained. That's good. So now that we have the necessary information about the representation of an atom, these are the characteristics of a given atom, or what characterizes an atom. It's the atomic number and its mass number. And we know the meaning of mass number, atomic number. We know the meaning of protons, neutrons, electrons, and where they are located. Now we can use our simulation to build atoms. And if you didn't get it well, the definitions and other explanations, you can go back, replay to get a better understanding of what we have been explaining before you go to the simulation and how it works. Here we have our simulation. The simulation is called Build an Atom. I remind you, it is found on opanda.xyz, the lab simulations. And we can start with this, the atom. Remember, an atom has protons, neutrons, and electrons. Protons and neutrons are in the nucleus, and electrons are on electronic shells. Here we have the nucleus, this is the nucleus, and these are electronic shells. Here we have protons, neutrons, and electrons. You can show the orbits, or you can show the cloud. When you show the cloud, what happens? We will see that. And here we have the periodic table. the periodic table will display the element you will build or the atom you will build. It will display this periodic table, the element to which, sorry, the periodic table will display the element to which the atom you have built belongs. Here you can show the charge of the atom you have built. If it is a cation, the charge will be positive. If it is an anion, the charge will be negative. And if it is a neutral atom, the charge will be 0. You can also show the mass number. Okay, we will see that. And you hide this, you can hide this, and you can also hide the periodic table. You can also show the name of the element. You can show if the atom is neutral or an ion, and you can also show if the atom is stable or unstable. Let's start with a proton. When you put there a proton, an atom which has a single proton is hydrogen. And here you can see that it is an ion because there is no electron. But when we put an electron, then it becomes neutral. And we can show the mass number. The mass number is 1. Remember, we have what we call isotopes. They have different masses. So this is an isotope of hydrogen. The first isotope has a mass of 1, and because the second has, in addition to the proton, it has a neutron, then the mass is 2. Now here we have the electron cloud. The electron cloud doesn't show the number of electrons, but it shows the negative cloud around the nucleus. Is this atom stable? You can show that. So this one is stable. So this atom or this isotope is stable. Let's show the orbits. Now let's add another neutron to form another isotope of hydrogen. This isotope has a mass of 3. You can see the symbol of the element has not changed because the number of protons is constant. The nil charge still is 0. What happens if we remove the electron? If we remove the electron, you can see now because the atom has lost a single electron, it is an ion and its charge is 1, but the mass doesn't change. Remember, the mass is concentrated in the nucleus, so the electrons are not considered when determining the mass. And you can see that the isotope, this one, is unstable. Now let's go to the second element. We add. Now we have a new element. When the number of protons change, you get a new element. The number of protons changes, you get a new element. You can see we have helium, but the helium is an ion now because we have not added electrons. The charge is 2. So we have to add 2 electrons to neutralize the charge of the 2 protons. So this is how you can keep on building more atoms and more atoms. You can check if they are stable. You can change the number of electrons. Here we have more electrons than protons, so the charge is negative. The mass is 4 because we have 2 protons and 2 neutrons. So you can keep on changing and you get new elements. Here we have an atom of lithium and it is unstable. You can see it is unstable. You can remove the name or show the name. When we add a neutron, you can see now the isotope is stable. So this is how we can keep on changing atoms, building atoms. Let's go to this symbol, chemical symbol here. Now we have a symbol, a box where the symbol will be shown. Let me start with the hydrogen. We have 1 proton, that is hydrogen, but it has a positive charge because there is no electron. We have an electron, now the charge is 0. It's a neutral atom. We have an atomic number of 1 and a mass of 1. We can build its isotope, hydrogen, with a mass of 2. Okay? So you can keep on changing the number of protons, the neutrons. You check if the atom is neutral or ion. Of course, you have to deal with the number of electrons to change the charge. And if you want to change the element, you change the number of protons. If you want to change the isotopes, you change the number of neutrons. And here is a game. If you think that you are ready to take the quiz, you are ready to play the game, here is the game. You choose your game, and then you answer the questions. You can also restart if the answer you have given is wrong. Let me give you an example. Let me give you an example. Here we have 8 protons, 10 neutrons, and 10 electrons. And here we have to find the element which has these characteristics. An element which has 8 protons is the atomic number of 8. That one is oxygen. And now you have to check if the atom is neutral or if it is an ion. It will be neutral if the number of protons and electrons are equal, but if they are different, then the atom will be an ion. It will be charged. And here we have 2 extra electrons compared to the protons. So this one is an ion, and then you check. Okay? So that is all I had today for the simulation. I hope you enjoyed. And now let's use this time to show you how you will take the quiz. The code of our quiz is VID 001005. If you are new to the system, these are the steps to follow when taking the quiz. You go to the website opanda.xyz, you click on login, login is here, and then you click on take a quiz. Take a quiz is here. And after that, you will type the code, that code I've shown you, in this box, and then you take the quiz. Thank you for watching. See you next time.